Alright, this video is about rolling offsets. There are a number of ways that a rolling offset problem can be displayed. One of them, I'll just show you right here. One method is like this. You got a three-dimensional box that shows pipe coming in. It rolls over off of its plane by 6 feet and then continues on in a parallel type fashion. The 4-foot rise and a 12-foot run. Another way to display the same rolling offset looks like this. This is what you're most likely to see on a drawing. Okay, this is perfectly vertical, and this shows how much off of vertical the pipe has rolled. 6 feet. Your 12-foot run and your 4-foot rise. And then this one here just gives you your pipe size, tells you what your rise, roll, and run are. It's mostly if you already have a pretty good idea, a good solid grasp of what a rolling offset looks like and where these dimensions come into play. So just pick whichever method or whichever diagram makes the most sense to you, and we'll go with it. I'm going to use this one here, and we're going to solve for the travel. We're going to solve the travel center to center. We're going to solve the end to end and the angle of our fittings. Okay, so first off, we're going to get our travel center to center. Travel center to center will be, okay, the formula that I like to use, a squared plus b squared plus c squared equals, is going to equal our travel. So we'll pull up our calculator. Okay, clear it out. It doesn't matter which side you call A, what side you call B, or what side you call C. Okay, so I'm just going to go right around the diagram. 12 feet. Make sure you include the dimensional feet and inches there. Squared plus 4 feet squared plus 6 feet squared equals 196 square feet. So now all you got to do is hit the square root button. So we know our travel is 14 feet center to center. 14 feet 0 inches center to center. Okay, now we got to figure out what our angle is so we can get our end-to-end measurement. We got to, since we know, let me change the color up here. We now know this side of our triangle. We know this side of our triangle. Now we've got to figure out that side of our triangle. Okay, again, we're going to use a squared plus b squared, so that will be 6 foot squared plus 4 feet squared, the square root of that. Let's see here. So let me go back to the calculator. Clear it out. 6 feet squared plus 4 feet squared equals, and the square root, 7 foot 2 and 9/16. So we know now that this is this dimension right here, 7 foot 2 and 9/16. Okay, so to figure out what this angle is right here, remember opposite over adjacent. The tangent is equal to the opposite side, which we now know, divided by the adjacent side, which we already had. So we just got to divide that by 12 feet, and that'll equal the tangent of our angle. Okay, let me pull up the calculator. Divide that by 12 feet equals 0.600925. That is our tangent. Okay, we want the angle. What angle does that tangent represent? So we're going to hit convert tangent. That's 31 degrees. Okay, so now we know the angle of our fittings. Our fittings are 31 degrees. Okay, now I figure arc lengths, I show you arc lengths and takeoffs in another video, so I'm not going to go that far into it in an effort to save time and file size on this video. So we're just going to go into the end-to-end measurement next. Okay, so now we gotta do our takeoffs for this 31 degree fitting. All right, we've got 4-inch pipe, a 14 foot center to center. Okay, we got 4-inch pipe, got nominal pipe size, we've got 14 foot center to center, and I think it was 31 degree fitting. Yeah, and a 31 degree fitting. So our takeoff for 31 degrees is the tangent of the degree divided by 2 times the radius. Okay, tangent of half the degree is, okay, we've got 31 divided by 2 equals, and then the tangent, which is 0.277 times the radius of 4-inch, which is 6 inches, nominal pipe size times 1.5. Okay, so our takeoff will be times 6 inches equals 1 11/16. 1 11/16. Okay, so we want our total takeoff. We know how much, we got to know how much to take off completely. So we got to times that by 2, and then we've got to add 1/4 of an inch for our gaps, our weld gaps. Okay, and it's 1/8 of an inch on each side for our weld gaps. Okay, so our total takeoff, let me see here, will be, okay, times that by 2 for 2 fittings, equals plus 1/4 equals, that ain't right, yes it is, 3 9/16. That is so small. 3 9/16 for a takeoff. Okay, so we got 14 feet. 14 foot minus 3 9/16. Okay, so we're dealing with, we need a foot over here. So I'm going to make this a 13 and put 12 inches here. Then I'm going to take 1 inch off of that and put it over here. Okay, that's 7/16. That's 8, and that's 13. So we've got 13 foot, 8 7/16 end to end. So we've solved our angle, our takeoff, our center to center, and our end to end measurement, the longhand method. I'm going to show you real quick how to do that with the calculator. Okay, I'm going to bring up that drawing real quick, and I'll show you the other way. If you have these written down, you can compare them to what we're going to get on the calculator doing it that way. Alright, let me go back to here. Okay, same thing. Now I'm going to pull up this right here, move it over so we can see everything. Alright, clear out the calculator completely, clear all. We're dealing with 4-inch pipe, so I'm going to put the pipe size in there. Makes sense, right? 4-inch pipe size. Okay, now on the calculator your offset is your rise. Okay, so we're going to plug in 4 foot offset, 12 foot run, and then 6 feet roll, which is convert travel. Gives us a length, which is exactly what we had, 14 feet for our travel. That's center to center. We're going to hit travel again. That gives us 13 feet, 8 7/16, which is exactly what we had. That's our end-to-end measurement. Hit travel again. We have a takeoff of 1 11/16, which is exactly what we had. Our gap is 1/8 inch. Our fitting is 31 degrees. And our inside arc is 2 inches. Center arc is 3 1/4. Outside arc is 4 7/16. And then it's going to go through so you can verify that you plug the right information in there. Our advance is the same as the run. It's just the calculator's language. Offset of 4 foot, which is our rise, and a roll of 6 feet, which is all correct. And that is how you solve a rolling offset, the longhand method, and by using the calculator. I hope this helps. Thank you.